To understand how permanent waving works, you need to have a basic understanding of the chemistry and chemical used during the process. Our learning objective for this lesson will be to explain the 4 chemical reactions that take place during permanent waving. Permanent waving is a 2-step process, where the hair undergoes a physical change caused by wrapping wet hair on perm rods, and then the hair undergoes a chemical change caused by the application of the permanent waving solution and neutralizer. When performing a permanent wave service, the size of the rod determines the size of the curl. The shape and type of curl are determined by the shape and type of rod used, and the wrapping pattern implemented. Because chemical changes are involved, you should always perform an elasticity test before perming the hair. To check the hair's elasticity, wet a single strand of hair and pull the hair in opposite directions. The hair should pull apart and return to normal. If the hair pulls and breaks, this indicates the hair has very low elasticity. If the hair does not return to normal length, this also indicates low elasticity. The hair's elasticity is the single determining factor on how well the hair will hold a curl. Alkaline permanent waving solutions soften and swell the hair shaft and open the cuticle layer, permitting the solution to penetrate into the cortex. Acidic solutions will close the cuticle layer and will not swell the hair shaft. Once a permanent waving solution has penetrated into the cortex, a chemical reaction known as reduction reaction begins breaking the disulfide bonds. The chemical process of permanent waving involves the following reactions. A disulfide bond joins the sulfur atoms from 2 adjacent polypeptide chains together. Permanent wave solution breaks a disulfide bond by adding a hydrogen atom to each of its sulfur atoms. The sulfur atoms attach to the hydrogen atom from the permanent waving solution, breaking their attachment to each other. Once the disulfide bond is broken, the polypeptide chains can form into their new curled shape. All permanent wave solutions contain a reducing agent. The reducing agent is the chemical that is used to break the disulfide bonds. The reducing agent commonly found in permanent waving solutions is known as thioglycolic acid. The strength of the solution is determined by the concentration of the thioglycolic acid. Stronger perms have a higher concentration of thio, which means that stronger perms will break more disulfide bonds than a weaker perm with a lower concentration of thio. Because acids do not swell the hair shaft, nor penetrate the cortex, it is necessary for manufacturers to add an alkalizing agent to the solution. The most common alkalizing agent added to permanent wave solutions is ammonia. Ammonia is highly alkaline with a pH of about 12. When manufacturers combine ammonia and thioglycolic acid, this creates a new chemical called ammonium thioglycolate, or more commonly referred to as ATG. Ammonium thioglycolate is the most common reducing agent used in permanent waving solutions. Ammonia is an alkaline chemical used to soften and swell the hair shaft and open the cuticle layer, while the thioglycolic acid is used to break the disulfide bonds. The pH level of the permanent waving solution is the second factor in the overall strength of a solution. Coarse hair with a strong, healthy, compact, resistant cuticle layer will require the additional swelling and penetration that is provided by a stronger and more highly alkaline waving solution. Whereas fine, porous, or damaged hair that already has an open cuticle layer will not require any swelling and should use a lower alkaline product. Using a higher alkaline product on porous, damaged hair can cause the hair to melt and break off. The alkalinity of a perm solution should correspond to the resistance, strength, and porosity of the cuticle layer of the hair shaft.